Okay, so here are the notes for section 12.3, surface area of pyramids and cones. It's very similar to 12.2, different formulas, but the ideas are still the same as far as, breaking it down and finding certain distances and lengths. So we're going to talk about again lateral surface area, which is surface area without the base, and then total surface area, which is with the base. Now, a pyramid. Okay, the first thing is to define a pyramid. Has a base. Well, a regular pyramid does, and that's kind of what they're working with here on some of these. But it has a base that is a regular polygon. Okay, the altitude is at the endpoint of the center of the base, and then all the lateral edges are congruent, and lateral faces are congruent isosceles triangles. Okay. Now here's the part that's different for this shape versus what we've worked with before. The height of each lateral face is called the slant height. So that's this height right here. That height right there is called the slant height. It's the height of one of the faces of the pyramid. It would be like this distance here as well if it were non-regular. Okay, but that's the new thing we have to measure with the pyramid. So you have your base, edges. Slant height again goes from the vertex to the side, and it goes down the middle. Because remember, on these, all the edges that are lateral edges are congruent because it's a bunch of isosceles triangles. Okay. And then everything else, yeah. So to find the surface area for one of these guys, okay, to do the surface area, here's how it works. How do I have these stops here? I know I have the one. So when you have your prism, this is again a pentagonal prism, or pyramid, sorry, pentagonal pyramid. So what ends up happening is whenever you cut this up, you cut right down these lines here, right on the lateral edges. In this case, there are 5 of them. We can't see one because one of them is blocked by the altitude. It goes right on the back of it, like back here. And then what ends up happening is you get this pentagon, which is your base. And then you get the 5 triangles. Now, to explain what's happening in the formula here, I'm going to cut over to another sheet of paper. Okay. So we have 5 pyramids, or not 5 pyramids, 5 triangles. So, excuse my poor drawing of a pentagonal prism. And then you have these triangles. Now, all these triangles are congruent. So I'm only going to draw one because imagine there's one here, one here, one here, one here. If I find the area of one triangle, it's 1/2 this base here times the height of the triangle. Well, we've already said that height is actually the slant height. And that we use instead of H because we have all these little letters to do, we call it letter L. That's a cursive lowercase l. So the surface area, the lateral surface area at least, is one is the triangle area times number of triangles. So in this case it'd be 1/2 base 1 times height times 5 because there are 5 triangles. Well, what we got to remember also is this base is regular. So all the sides are the same. So base 1, base 1, so base 1, so base 1. So I really just could call it a base. If I do the perimeter of the base, it's going to be base 1 plus base 1 plus base 1 plus base 1 plus base 1. Oh, that's really 5 of those bases. Look what I got here. 5 times bases. So it's 1/2 5 times the bases times the height. Well, wait a second. I can replace 5 bases with perimeter, and I can replace height with slant height. There's the formula for lateral surface area. You just find the perimeter of the base, multiply by the slant height, and then multiply it by 1/2. And the reason it's 1/2 is that all those guys were triangles, so it's 1/2 of all those. And then if you want total surface area, you just add the area of the base plus 1/2 perimeter times slant height. Nice and easy. So lateral surface area of a pyramid, total surface area of a pyramid. 1/2 PL, 1/2 PL plus B. Now, if it's a cone, okay, this might seem like some kind of magical mystery, crazy stuff how we get there, but what you realize is that a cone is really a lot like a pyramid, except for the base is now a circle. So if the formula for a pyramid is area, total surface area equals area of the base plus 1/2 perimeter of the base times the slant height, for a cone, the base is a circle, so pi r squared, plus 1/2 the perimeter of the base. Well, that's circumference, which is 2 pi r times L. And what ends up happening is you get pi r squared plus the 1/2 and the 2 canceling, pi r L. There we go. That's the formula for total surface area of a cone. And if you want just regular surface area or lateral surface area, just cut off this and just do pi r L. So lateral surface area, pi r L, total surface area, pi r L plus pi r squared. Okay, so let's look at some examples. So find the total surface area, because it does just say surface area, so we'll do total surface area. I'm missing. Sorry, just a second here. Yep, I'm missing one. Okay, so find the total surface area of the square pyramid to the nearest tenth. Okay, so here we go. We look at this shape. Okay, the reason I picked this one to look at first is that they don't give you everything. They give you the base. That's pretty easy to do. I'm sorry, I should have paused this. Okay, now we're back. So they give you the base perimeter. Okay, so we have, all right, 8, 8, 8, 8. So we go to do our surface area. Total surface area is area of the base plus 1/2 the perimeter of the base times the slant height. Well, in our case, the perimeter of the base is 8 times 4, which is 32 because it's 4 sides all added together. The area of the base is also easy because it's a square, so it's just base times height, which is 8 times 8, which is 64. Both easy numbers to find, perimeter and area. The tricky part is that slant height. And if you look back at the drawing of it, you'd say, okay, well, this distance right here is my slant height. And the question is, well, what in the world do I do to get that? Because it didn't give me that length. It gave me 6 here, and it gave me 4 here, but how do I find the slant height? Well, hopefully by me drawing that in green, you caught it that, oh, hey, that's a right triangle, which it is. So we have a right triangle where this is 4, this is 6, and then here's the slant height. So what we'll have to do to find the slant height is the Pythagorean theorem. So L squared equals 4 squared plus 6 squared. L squared is 16 plus 36. L squared is 52. Take the square root. Square root of 52. Oops, wrong button. Second square root 52 is 7.2111. So L equals 7.21. So there we go. So now to find our surface area then, area of the base plus 1/2 perimeter of the base times the slant height. Okay. Now you can plug that in as a decimal, or if you're really feeling fancy, you could just do 64 plus 0.5 times 32 times the square root of 52. And we get 179.37. Nearest tenth then would be 179.4. And I'm trying to think, did they have units on that guy? Yeah, they did, meters. So meter squared. Alrighty. Okay. All right, then next problem. Surface area of a cone. Okay. So Um, we have, I don't know, yeah, we have 3.2 centimeters and 1.4 centimeters. Okay, so they're asking for total surface area, which means pi r squared plus pi rl. Um, our radius is 1.4, and then they gave us the slant height this time, 3.2. So this one really is pretty straightforward. Pi times 1.4 squared plus pi times 1.4 times 3.2. And then we just basically get our calculator out. So pi times 1.4 squared plus pi times 1.4 times 3.2, which is 20.2. And it was centimeters squared. Okay, next oh, that's it. Okay, I kept it short. So, all right, I'll see you in class, and yeah, let me know if you have any other questions.